Good morning, my dear students. So today we are going to discuss a good topic, that is ANOVA One Way Classification Table Model. So here, if you observe carefully in the previous class, what we discussed regarding the introduction of the chapter. Okay. Then here, what happens here? Previously we discussed regarding the ANOVA introduction. ANOVA is a powerful statistical tool. ANOVA is also called as analysis of variance. Okay, previously when only the sample size is 2, then we need to apply only t-test. Okay, but when the sample size is 3 or more, then automatically here what happens here, the application of ANOVA is came in force. Okay, and here the basic condition is here, while you are selecting these ANOVA technique, either one way or two way, before you are going to apply this model, you should see that all the samples should be belongs to only one family. We call it as a homogeneity. The next, we have seen a small example also. 5 fertilizers are applied to a 4 plots, yield of wheat. Okay. The next, the another important thing is here. This ANOVA was introduced by Professor Ronald A. Fisher in the year 1920. Okay, this is the important name you have to remind each and every minute. Why? Because the chapter says that while in the question paper they will ask apply Ronald A. Fisher in this model way, or otherwise say they say ask apply Ronald test or F test. F is nothing but Fisher's test. Okay, then we have seen the assumptions also. Then come to these techniques of ANOVA. Here we have two types of techniques in ANOVA. The first one is the one-way classification. The second one is the two-way classification. Okay, after doing the problem, it is a customary to summarize all the calculations of for sum of squares together with the number of degrees of freedom and the mean squares in the table called analysis of variance table, generally abbreviated as ANOVA. The specimen of ANOVA table is given below. You observe carefully, this table is very much important. If you had this table, automatically the good marks are there in your hands or in your pocket. So you observe carefully ANOVA table, one-way classification model. So here there are 5 heads are there, that is the source of variation, sum of squares, degrees of freedom, mean squares, variance, ratio of F. These are the 5 heads you have to remind carefully. Okay, source of variation, sum of squares nothing but SS, we call it as SS. Degrees of freedom is called as here V. Okay, mean squares means here MS. Then variance ratio of F. Variance ratio of F is also important. Okay, then here in the source of variation, you need to remind these table composite, that is between samples, within samples, between samples, within samples. You have to say for more than 10 times or more than 20 times, automatically you will remember this between samples and within samples. In between samples, first of all, you are going to find out the value of SSC. Okay, SSC. The next degrees of freedom, that is V1 is equals to C minus 1. C is nothing but columns. Okay, then next after getting this C minus 1 value, here you go for mean squares. Mean squares is nothing but MSC is equals to SSC divided by C minus 1. This SSC is we have taken from these place. Okay, observe carefully, SSC. Okay, the next C minus 1. V is equals to the value you are going to get, that value should be denominator and SSC value will be numerator. This numerator is divided by the denominator. Then finally you will get a MSC value. Then this MSC value will be keep aside here. Then go for the again source of variation, that is the second one, within samples. Variance within samples. Within samples, you can say within sample, between sample, within sample. In within sample, first of all you have to find out SSE value. Okay, after getting SSE value, V2 is equals to N minus C. Then your the same procedure what you applied in the between samples, that is SSC divided by C minus 1. the same formula, same application you need to apply here also. That is SSC divided by n minus C. Then finally you will get a MSC value. Okay. Then after getting MSC and MSE values, go for variance ratio of F, that is MSC divided by MSE. Okay. Then the next one is the total here. Total is nothing but SST. Okay. The total means here SSC and SSE. For example, SSC you got 10 and SSE you got 90. The final total is 100. Then after that, degrees of freedom here is K is equals to N minus 1. Okay. N minus 1. So you will get some doubt what is C and what is N. Okay, you observe carefully. I will show one small problem. Then you will get a clarity regarding C and N values. Okay, you observe carefully a small problem. Here, see, problem will be like this. Schools A, B, C, D. Okay, these schools belongs to a homogeneity group here. Homogeneity means they belongs to educational sector here. School A, School B, School C, School D. Okay, here the values are given 8, 10, 12, 8, 7, 12, 11, 9, 14, 4. Then 18, 12, 16, 6, 8. Then school D here 13, 9, 12, 16, 15. Okay, in this way the problem will be there. Here the additional information is given in the sometimes what happens given question, no information will be available. By observing these question only, you have to do the problem. After getting SSE value, okay, you have to insert on the above table. So you observe carefully what is C here. How many columns are there here? 1, 2, 3, 4 columns are there. Then N stands for total number of individual observations from the given table. How many observations are there here? From school A, you have 5 observations. In school B, you have 5 observations. Okay. Then school C, again 5 observations. School D, 5 observations. Total observations are here. 20 observations are there. Okay, I think you got a good clarity here. C minus 1 means nothing but here you will get 4. How many columns are there? 4 columns are there. 4 minus 1 is the final answer is V1 is equals to 3. Then V2 is equals to N minus C. N indicates 20. 20 minus columns are, how many columns are there? 4 columns are there. N minus, 20 minus 4 means here you will get 16. Okay. Then if you do total, the first thing is if you do total 3 plus here 16, that is 19. Otherwise, simply don't do total. K is equals to N is equals to how many samples are there? 20 samples are there. 20 minus 1 is 19. Again, same answer you will get. Okay, whereas here SST is equals to this one. SST is equal to total sum of squares of variations. Then SSC is equals to sum of squares between samples. Sum of squares between samples. In the next class, we will discuss the steps how to get this SSC, SSE values. We are going to discuss steps also. After that, we will solve one problem. After solving this problem, you will get a complete clarity regarding this ANOVA table one-way classification model. Before we are going to start the problematic part, okay, the students, what you have to do, your major contribution should be you have to learn, you have to buy this table, very simple table. You have to remind this table. If you remind this table, automatically the question mark will be there in your mind while you are doing the problem. The first thing is you have to find out the SSC value. Okay, you know that C means what, N is what, you will get V1 and V2 values, but you should get SSC and SSC value, because with the help of this SSC and SSC value, you are going to get MSC and MSE values. Okay, here MSE is equals to mean sum of squares between columns. Then again MSE is equals to mean sum of squares within samples. Okay, between samples, within samples again. Okay, then finally you will get MSC by MSE. Then you will get some value. Okay, what is that value? For example, you got 6.1 or 1.0. Any number you will get. That number should be compared with the table value, the critical values. Okay, critical values. Critical value means here, if you have any statistical book, in the back side of that book you will get you will have a small table. You will get it xerox, or otherwise I will provide that um, table also. In the table, ANOVA 5% table or 1% table will be there, or Fisher's 5% or Fisher's 1% table will be available. In that table, V1 will be horizontal values will be there, and V2 is vertical values will be there. Okay, see here how much you got, 3 you got, and here is 16. At the place of 3 and 16, what is the common value you have? For example, 16.1 or 15.1 will be there in the table. These f value 1.0 or 6.0 should be compared with that table value. If it is less than the calculated value, okay, you done the calculation, that is MSc by MSc. If you done the calculation, the calculated value should be compared with the table value, that is critical value. If it is less than the calculated value is less than table value, then you have to accept the null hypothesis, that is you need to accept the H naught. In this way you have to write. Okay, the next one here, small note 1 and note 2 is there. These are the very much important. Okay, while you are doing this problem here, you observe carefully. Note number 1, the same procedure for analysis of variance is applicable for both the equal and unequal samples here. Both the equal and unequal samples means in the given question paper. Okay, sometimes equal and unequal values will be there. What are the unequal and equal values here? You observe carefully by observing this problem. Okay, here all the values in schools A, B, C, D, all the values are equal values are there here. Equal means not same number, but you observe these all the tables here. How many values are there in school A? How many samples they have taken? From 4 schools they have taken 5 values, 1, 2, 3, 4, 5. In the same case, how far they have taken from school A, this taken from school B also, 12, 11, 9, 14, 4. See, 5 values and 5 values, equal values are there. Again here 5 values, here 5 values, equal values are there. For example, okay, here 10 is not there. Okay, students, 10 is not there. This is a unequal table here, not equal table here. And here, for example, there is no 9. It is a unequal table. Again here 12. Okay, in this case you observe this table here, only 4 values are there. Again in the B school also 4 values are there. In the school C school also 4 values are there. But coming to school D, 5 values are there. Okay, in the given problem, equal or unequal values are given. The same procedure, same table, same SSC value will get, same procedure we have to follow. That's the note number 1 explanation here. Okay, the next one here, you observe carefully. Next one here, same procedure for analysis of variance is applicable for both equal and unequal values. Equal values means in the given table all the values should be equal. School A, 5 numbers are there, 5 variables are there. In the same manner, 5 samples, 5 samples, 5 samples. Unequal values means here already we explained. I think you got the next node number 2. Node number 2 means nothing but here, very simple. This is assume 5% here, 5% level of significance if LOS is not given in the question. Okay, LOS is not given in the question. LOS indicates here 5% and 1% means here this should be applied at the end of the problem. Okay, after inserting all the values, you calculated MSc by MSc. MSc nothing but here F is equals to, this is a small formula, F is equals to variance between the samples divided by variance within the sample. Okay, finally you will get some value, some figure. Either it is a fraction number or a whole number or a even number you will get. After that, that value should be compared with the table value, the critical values at 5% or 1%. Okay, the table will be there. So you observe, I am giving a small example here. So you observe this paper. Okay, this is small white paper. In this paper you observe here critical values of F distribution at 5% will be written. In the back side, critical values of 1%. of F distribution will be there. Okay, V1 values and V2 values will be there. Here horizontally V2 values will be there, V1 values will be there here. 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5, 6. Here vertically it will be written. Okay, this is 5% and backside is 1% will be there. Okay, anything is not mentioned, nothing is mentioned regarding LOS, then you have to assume that it is a 5% critical values table. You have to consider only, then only you will get a right answer. Okay, these are the node number 1 and node number 2. Okay, the node number 1 is, again I am repeating here, the same procedure for analysis of variance is applicable for both equal and unequal sample sizes. Then node number 2 says assume 5% level of significance if LOH is not given in the question. You observe this question here: to assess the significance of possible variation in performance in a certain test between grammar school of a city, a common test was given to a number of students taken at random from the senior fifth class of each of the four schools concerned. The results are given below. Make an analysis of variance of data. Okay, here schools only one side information is available, so you can decide that this is a one-way classification model problem. And here then after the solution will be there. In the next class we are going to solve this problem also. See, 5% yellow is not given and 1% yellow is not given, so we have to assume that first node number 1, you have to observe node number 1, all the values are equal is there or unequal is there, equal values are there, then you have to follow the same procedure. Unequal values also sometimes you will get in the question paper, then also you have to follow the same procedure. Okay, this is a important node number 1. In the node number 2, in the given question 5% LOS is not given in any running matter or 1% LOS is not given. In this case, what you have to do, you have to assume that it is a 5% LOS only. Okay, 5% LOS only. In the 5% Fisher's table, see, in the, again I am showing these values. Okay, the 5% Fisher's table, you go for the 5% only. Okay, ignore 1%, accept the 5% here. These MSc and MSc value, you will get some value. Okay, that we call it as F is equals to variance between the samples divided by variance within the sample. After getting that value, this value is called calculated value because we calculated that value. After getting these calculated value should be compared with the critical value or table value. Then only you have to take the decision there whether accept or reject the null hypothesis. So again I am reminding, in the next class we are going to discuss the steps to calculate ANOVA one-way classification. Okay, before we are going to discuss regarding the steps, you have to buy this table compulsory. If you buy this table, then complete you will get a good clarity. But in the meantime, while you are preparing for this ANOVA one-way table, you will get different doubts. The doubts will be clarified in the next class while we are solving the problem. So again, I am repeating this table. You observe carefully. ANOVA table, one-way classification model, sources of variation, sum of squares, degrees of freedom, mean squares, variance, ratio of F. Okay, again I am repeating here: between samples, within samples, between samples, within samples, between samples, within samples. Sum of squares here SSC, within samples SSE. Okay, SSC, SSE, the total we call it as SST. See here, common point is here is this SS and SS. It is common for in the 3 columns here. Then C you will get alphabetical order wise. You observe, C will get first, then E will get first, second, then T will get the third here. Okay, I think you got a good clarity regarding this one: SSC, SSE and SST. Then degrees of freedom here, V1 is equals to C minus 1. Columns, in the given question only 4 columns are there, 4 minus 1. Sometimes the question will be like this: 5 columns are there, 6 columns are there, 10 columns are there, 8 columns are there. Then you have to take the column numbers, how many columns are there. That is V1 is equals to C minus 1 and V2 is equals to N minus C. N indicates total number of individual samples here. You have to observe carefully. Why? Because sometimes equal and unequal samples will be there. Okay, at that time only where the number is there, in that column count that numbers, and you have to take a decision that n is 20 or n is 15 or n is 16. Okay, c is indicates columns, n minus c. Then the final is k is equals to n minus 1. How many individual samples are there? Minus 1. Okay, you will get, then I think you understood this degrees of freedom also. Then mean squares are there. MSC divided by MSC is equals to SSC divided by C minus 1. SSC, then C minus 1. Numerator, then denominator, then you will get some value. Then MSC is equals to SSC divided by N minus C. N minus C. Here already the SSC value is there and N minus value, N minus C value also available. Then you will get MSC value. After getting these both the values, okay, this MSC value we call it as variance between the samples. MSE value we call it as variance within the samples, and finally it will be divided. Okay, MSC divided by MSE. Then finally you will get some value. With that value, in the given question, 5% is given or 1% is given. You observe carefully. If 1% is given, follow Fisher's 1% ANOVA table. Okay, these calculated value MSC by MSE, the calculated value got, these calculated value should be compared with the table value at 1%. If 5% is given, means 5%. Okay, if anything is not mentioned, 5% and 1% is not mentioned, then you have to follow 5% only. Already in the note number 2 I have written here, you observe carefully. For unequal values, note number equal or unequal values, same procedure you have to follow. That note number 1 says, and note number 2, assume 5% LOS if LOS value is not given in the question. So I think you got a good clarity regarding the ANOVA one-way classification model table. So students, please observe this table carefully and by heart this table. Nothing is new here. It is a only alphabets you observe carefully. So I will take the next class. In the next class, we are going to discuss the steps to get SSC value, the steps to get SSE value. Okay, friends. So thank you very much for listening this class. We will meet in the next class. Okay. So thank you very much for listening the class. Okay. Thank you very much.